Now we're moving to example 2. It requires us to find the points on the hyperbolic cylinder that are closest to the origin. So again, it's the idea of this example is the same thing as in example 1. It wants us to minimize the distance between the origin and the points that are on that cylinder. And the first, it is the first method, the first solution. It's done like the one that is done in example 1, but we didn't do it that way. But solution 2, it's minimizing the distance using Lagrange multipliers. So we are using Lagrange multipliers. In all of the cases that we have got, we are using Lagrange multipliers because it's suitable for every kind of example. There is no example that we cannot use Lagrange multipliers for, but the other method, it changes from an example to another one. So here we are minimizing the distance function, which is x squared plus y squared plus z squared under the square root. And as the previous example, what we did, we minimized the function f that's equal to x squared plus y squared plus z squared instead of the square root. Why? Because we said this function, the square root function, is strictly increasing, and its outputs are always positive numbers. That's why we could use that function without the square root to minimize the distance. And we are minimizing the distance of this function with respect to which function? With respect to g of x, y, z. That's equal to what? That's equal to x squared minus z squared minus 1. Okay? Now using Lagrange multipliers to find the minimum distance between g and f. So we have got grad f that's equal to lambda grad g. Okay? Grad f, again, we know that that's equal to 2xi, derivative with respect to x, with respect to y, with respect to z. That's 2yj plus 2zk. And that's equal to lambda multiplied with grad g. That's 2xi. We have got 0. I'll simply write 0 so that you can later do the comparison between the two sides of the equation. And minus 2zk. Okay. Now those two equations are equal to each other if they are equal to each other component-wise. So we have got 2x is equal to 2 lambda x. Okay. We have got 2y is equal to 0, and we have got 2z that's equal to minus 2zk. Oh, sorry, not the k. 2z lambda. 2z lambda. Okay. Here, from here, we get that y is equal to 0. From here, we get y is equal to 0 directly. So we directly found the value of y, one of the points, one of the coordinates, let me say. From here, here either x is equal to 0 or x can be any value. Okay, either x is equal to 0 or x can take any value, can take any other value to set this equation equal to each other. But x is not equal to 0. Okay? Why x is not equal to 0? Because if x is equal to 0, subject to that condition that we have got, what will we get? We get 0 squared minus z squared minus 1 is equal to 0. From here, I get what? I get z squared is equal to minus 1, which is something impossible. So we are excluding the case that x is equal to 0. We only consider the case that that x can be any other value. Okay, that x can be any other value. So when x is any other value, we divide both sides of this equation by x. So we get lambda is equal to what? Lambda is equal to 1. Okay? So when lambda is equal to 1, what do we get? We get, if you're substituting this lambda equal to what? If equal to 1 into that equation that we have got for z, okay, here, what do we get? We get 2z is equal to minus 2z, because lambda is equal to 1. Let me put the 1 here so that we know we have got it from here. So 2z is equal to minus 2z. Well, this equation is only true when what? When z is equal to 0, or else this equation cannot be true for any other value of z. So now if you look at what we have got here, we know that y is equal to 0, okay, and z is equal to 0, and x can take any value. So the point that we have got here, the point that we have is x 0, 0. Subject to what? Subject to the condition that x squared minus z squared is equal to 1, or let me say minus 1 is equal to 0. But we know that z is equal to 0, so x squared, what do we get from here? We get x squared is equal to 1, because z squared becomes 0, and we take 1 to the other side, so x squared is equal to 1, and from here we get that x is equal to positive or negative 1. So the points that are on that cylinder and closest to the origin are what? The points that we found. It can be positive or negative 1 with 0, 0. That means 1, 0, 0 and negative 1, 0, 0 are those points that are on the cylinder and are closest to the origin.